In 2015, one star dimmed by 22%. And for a moment, serious astronomers could not rule out that we were watching an alien megastructure pass in front of it. The headlines were wrong, but the truth turned out to be stranger than 462852, a perfectly ordinary sun-like star, about 1,400 light-years away, in the constellation Cygnus. For 4 years, NASA's Kepler space telescope stared at it, along with 100,000 others, watching for the tiny dips in brightness that betray a passing planet. A planet like Jupiter blocks maybe 1% of a star's light. In a clean, repeating dip, you can set your clock by. This star dropped by 22%. And it did it on no schedule anyone could find. Sharp, deep, ragged dips, some lasting days, some with strange asymmetric shapes, then nothing for years at a time. It was first flagged not by a supercomputer, but by volunteers in the Planet Hunters project, ordinary people scanning the light curves by eye. They saw something that did not fit any planet, no clean shape, no rhythm. And they were right to be puzzled. The data was clean, repeatable, and completely unexplained. So the astronomers did what good astronomers do. They tried one by one to make it boring. Was it a flaw in the telescope? No. Kepler saw thousands of other stars cleanly at the same time. Was the star young, still wrapped in a planet-forming disk? Its light showed none of the warm infrared glow that disk would give off. Was it a chance alignment? Another object photobombing the data? Nothing lined up. One genuinely strong idea survived for a while. A swarm of giant comets, broken up and strung along an orbit, passing in front of the star. It was the leading natural explanation in that first paper. And we should be honest, it stayed in the running. But none of these answers fully accounted for blocking nearly a quarter of a sun-like star's light. The data was real. The cause was not yet known. And here is where the story usually gets told badly. So let's tell it properly. A credentialed astronomer, Jason Wright, and his colleagues raised a careful, explicitly speculative possibility that the irregular dimming was consistent with, not proof of, a Dyson swarm, an array of structures built by a civilization to harvest a star's energy, blocking its light in uneven, unplanet-like ways. Mark this clearly, it was offered as a hypothesis of last resort, the thing you check after the natural explanations, not instead of them. The scientists said so themselves. Telescopes that listen for alien signals turned toward the star. They found nothing. No radio, no laser, no technological signature at all. The megastructure was a real hypothesis, honestly proposed, and it was about to be honestly tested. The turning point came in 2017, and it is the heart of this whole story. Think about it this way. A solid object, a planet, a megastructure, a wall of rock, blocks all colors of light equally. If you stand behind something opaque, it dims the blue and the red by exactly the same amount, because it simply isn't letting any light through. So a team led by Tabitha Boyajian, the astronomer the star is now nicknamed for, funded by a public Kickstarter campaign of thousands of ordinary backers to buy the telescope time, watched the star dim again, in real time, and measured it color by color. The star dimmed more in blue light than in red. That single fact rules out a solid object. Whatever was crossing the star was letting red light through more easily than blue. And that is the signature of small particles. Fine dust. A megastructure would not do this. A cloud of tiny grains does exactly this. The alien hypothesis was not dismissed by ridicule. It was falsified by data. That is the difference between a headline and a measurement. So the leading explanation today is fine dust, most likely an uneven swarm of dust, and the debris of exocomets drifting around the star and crossing our line of sight in clumps. The wavelength test fits it, the irregular timing fits it. But leading is not the same as settled, and the honest awe lives in the gap. Where did all that dust come from, and why is there so much of it around a quiet, middle-aged star? And there are hints from older photographic plates going back a century that this star may have been slowly, steadily fading the whole time, a long, gradual dimming that drifting dust clouds alone do not cleanly explain. Those questions are still open, so here is the honest accounting. The dimming is real. Kepler measured it. The megastructure was a serious hypothesis, raised by serious people and then falsified by the color of the dimming. Fine dust is the leading answer, and a strong one. But the source of that dust and the slow century-long fade are not yet solved. A star that fooled the world, not because anyone lied, but because the universe handed us a genuine puzzle, and we tested our way through it. If you like your wonder honest, what we've proven kept separate from what we're still chasing, there's a free one-page guide in the description. Because the universe didn't need to be aliens to be astonishing. This is Cosmos, tested,